Hi, everyone. Welcome to our chat. Thanks for joining us today. I'm Maria Gallucci, and I'm joined today by my fellow reporters, Jeff St. John and Julian Spector. Just a quick programming note, Eric Westhoff will not be joining us, so it'll be three of us. So this week at Canary, we focused our coverage on Renewables Recycling Week. It's a pressing dilemma that affects not just the clean energy industry, but obviously the whole planet. We know that we're going to need to build and deploy orders of magnitude more solar panels, batteries, wind turbines to meet the challenge of limiting global warming. But we know at the same time that's going to mean billions of tons worth of equipment is eventually going to reach the end of its useful life. So here at Canary, we wanted to take a hard look at this question of what do you do with all that equipment, and how do you make sure it doesn't wind up in landfills? And also, how can we make sure that the minerals and materials used in these products can kind of be regenerated and harnessed to build new products as well? So we decided to report on this because, one, it's important, but two, it's important that policymakers and companies start thinking about these questions as soon as possible before the problem really starts to get ahead of them. And so backing up a bit, we kind of operated under this sort of general premise that clean energy economy and fossil fuel economy are fundamentally different, right? Clean energy involves using inexhaustible natural resources like wind and solar to power our lives. And the fossil fuel economy involves burning finite resources and in the process, creating harm for the climate, environment, and people. But obviously, clean energy equipment itself doesn't it has some impact, right? And we need to kind of grapple with that. So today, the three of us are going to talk about what we learned in the course of reporting our stories. And we're also going to open up to audience questions. So you'll see there is a Q&A section on your right-hand side that you can enter questions into. And even if you don't have a question of your own, you can upvote somebody else's. Well, great. So with that spiel, I will kick us off. Jeff, you wrote the big picture piece that sort of opened Renewables Recycling Week. Can you talk about this idea of, why, if the problem of clean energy equipment going out of service is kind of far on the horizon, why is it so urgent to think about now?
Yeah, thanks, Maria. And thanks everyone for joining us today. The reason we think it's important to write about, right, is because we need to get started now to get ready for what's coming. Right now, the demand for new solar and wind turbines and lithium-ion batteries is much higher than the volume of the same products that are reaching the end of their useful lives. In other words, there's not really enough value in the volume of stuff being thrown out today to make a dent in the volume of the stuff that is being built and deployed and which needs to be built and deployed. But that's going to change pretty quickly. There are a lot of stats out there that indicate that fact. By 2030, the world's going to be decommissioning about 8 million tons of solar panels per year. And that's going to reach nearly 80 million tons by 2050, according to the International Energy Agency. World Resources Institute indicates that the stats for lithium-ion batteries from EVs are going to kind of skyrocket from about 600,000 metric tons being disposed of by 2025 to 11 million metric tons by 2030. So the question is, how do you scale up an industry to be ready to manage that massive growth in volume? The problem right now is costs of recycling are too high, and the values for what you can get out of today's recycling processes and volumes are too low to justify investment on pure economic terms today. We talked to some experts at NREL, National Renewable Energy Laboratory, that told us that solar recycling costs between $15 to $20 to $30 to up to $45 per module today in the U.S. The DOE has launched an effort to get that down to $3 per panel, which is in striking distance of the $1 to $5 it costs to landfill a panel. And as for what a recycled solar panel is worth, that really depends on whether you're just getting back the aluminum and glass that makes up most of the weight, which is not worth that much, maybe a couple bucks, or the far more valuable copper and silver embedded in the solar cells themselves, as well as perhaps the silicon, which are much harder to extract and refine to a reusable form. Lithium-ion battery recycling is about the same situation. It can cost well more than the value you get from recycled materials to move lithium-ion batteries through the recycling process, or it can yield a positive return. I've seen numbers in the kind of negative to plus $20 per kilowatt hour of battery capacity on those. And that really all depends on the kind of battery you were talking about and the value of the metals inside it, the kind of recycling process, and how energy and cost intensive it is. It's the cost of recovering and transporting the spent batteries to where they need to be recycled. But one of the most critical factors is the volume of batteries you're able to get and how fully you can utilize the enormous capital cost of the recycling facility that's going to be turning them into value, right? And it's that volume and capacity utilization issue that's really key to understanding why regulations that mandate recycling are so important right now. That's also why the European Union, which has regulations on this front, is so far ahead right now compared to the US, which lacks them. It's also why I think automakers and recycling companies are forming up the partnerships that are really driving recycling in the US today, as well as around the world. They need each other's capacity. And I know I'm kind of running on here, but there's an important, I think, bit of logic to talk about when we talk about how much we can get out of recycling versus what it's worth. The IEA projects that if we really invest in recycling lithium-ion batteries, we could maybe reduce the demand for copper, nickel, cobalt, and lithium for the batteries we're going to need by about 10% by about 2040, which doesn't sound like a lot, but there's a potentially massive economic and environmental benefit to those companies or countries that can mine their trash instead of mining the earth. DOE's Resell Center, a battery recycling consortium, has data showing that it takes about 10 tons of ore to get you the same amount of lithium you can get from a ton of recycled batteries. The ratio for cobalt is about 20 to 50 tons of ore for each ton of spent batteries. And that means less cost, less energy, less emissions, less waste byproducts. So you can see how that marginal value is going to become increasingly important for, like I said, companies and countries that can establish an early competitive advantage in the recycling field.
Thanks, Jeff. And yeah, so obviously you talked a lot about the sort of economic and policy related challenges to recycling. Another thing that the three of us kind of discussed in our stories was the technical challenges, sort of the difficulties involved with actually picking apart these materials. In the case of my story, I wrote about wind turbines. So about 85% of the entire turbine is considered to be fairly straightforward to recycle. You have the steel in the towers, the copper in the wiring, the electrical wiring, etc. But that remaining 15% is really difficult because it's kind of meant to not break down ever, or at least within a few decades' time. It's the fiberglass or the carbon fiber that's embedded in plastic resins to kind of form this indestructible armor. And that's particularly challenging to break apart. And also the fact that these blades, could stretch hundreds of feet long. If you've ever seen one on the road or pictures of one, that they can fill up enormous truck beds. And they're also molded into these kind of awkward shapes of uneven teardrops, which makes them more aerodynamic, but it's not as easy as recycling or a tin can or a glass bottle. There are many components and they're not meant to be broken down. So I'm curious, maybe starting with you, Julian, and then Jeff, what some of the unique challenges there are to recycling solar panels and batteries.
Yeah. Well, hi, I'm Julian, joining you from a supposedly soundproof booth in East Hollywood. And yeah, batteries, definitely not an aluminum can. It's not just one material. It's a whole number of materials that are, in some cases, the metals are powdered, and then you've got the liquids and the electrolytes and the metal casings around that. So, there's not anything kind of fundamentally barring humans from being able to efficiently take these apart and get the different pieces out. But currently the issue is just that recycling capacity has not been built with the intention of actually extracting all the valuable components. When I was digging into the state of the industry, some of the conventional techniques that have been used are like, there's pyrometallurgy, where you basically put the batteries in a furnace and burn off quite a lot of the material, ejecting toxic, air pollution in the process, and then you get kind of this metal slag coming out that you can sell for a bit of the nickel and maybe cobalt, and that kind of goes to this low value metals commodity stream. Just people didn't build their factories many years ago with the intent of like capturing the valuable materials to make new batteries. So that's starting to change because suddenly, there's massive demand growth for new batteries, and there's this new cohort of up and coming startups that have realized, all the materials for a cathode are in an old cathode. So if you can figure out the techniques to efficiently extract them, then suddenly you have a much easier path to building new, producing new cathode materials than the alternative, which is go out, mine new ores from the earth, process those, refine those, ship them around the world to different steps of the supply chain, and then eventually you end up with high quality cathode materials. So yeah, and then there, people are working on better ways to like break down the cells to speed that up, to the extent that you can avoid labor intensive, like highly manual processes. You can save on the cost of dismantling, and yeah, it's a solvable problem from a technical perspective. We don't need any mind-blowing breakthroughs, but it's a matter of honing these techniques, getting the right materials pulled out of the old batteries, and then scaling capacity for that.
Yeah, Maria, it's a lot similar for solar panels. They too are built largely to be indestructible rather than to be recyclable. You can think of a solar panel as kind of a sandwich of materials. You get glass on top, aluminum frames, kind of plastic on the bottom. These make up most of the weight of the panel, the glass and aluminum. And the actual photovoltaic elements make up the delicious and expensive filling, with copper, silver conductor, and PV grade silicon for the most of the world's panels that are polysilicon. And that filling is encapsulated in protective layers of transparent plastic. That's what you need for a panel that can sit out in the elements for decades at a time and keep generating electricity efficiency, but it doesn't make for easily taking them apart and breaking them back down into their constituent materials, which is why most of the solar recycling that is happening today really focuses on getting those aluminum frames, get a few bucks per panel out of that, and then grind up the glass so you can turn it into cullet, which is, I guess, a filler material for construction. Or maybe get a couple bucks more out of that, and that's only for a really small percentage of the solar panels that are being recycled, at least in the US today. The European Union has taken a lead in pushing further, mandating solar panels used in the EU are recycled, assessing a fee on the panels that come into the country to pay for that recycling under its broader kind of electronic waste recycling structure. And Europe is also home to the world's first dedicated solar recycling facilities, rather than kind of general recycling. And it's largely taken the lead on setting guidelines for processes that can get at that valuable inner filling, right? And our colleague Eric Wessoff wrote a story about a US-based startup that's working on the same thing, trying to get that silver out primarily. And that's an important way to extract full value, but there's a great deal of uncertainty around that. That global metal prices are volatile. You never necessarily know what your output per weight is going to be worth. And the same things that might drive solar panel manufacturers to reduce the cost of panels by finding alternatives to those more costly metals and materials could reduce the value that comes out of the recycling processes that are designed around recapturing them. So there's a lot of uncertainty and a lot of risks, really, for folks who are looking at really significantly, putting a lot of investment into this.
Yeah, and that was actually something that I came across with the wind turbine recycling piece is if you subject these sort of fiberglass blades to high temperatures, so chemical processes like pyrolysis or what have you, ultimately you could recover the fibers, but are they going to be degraded? Are they still going to be the quality that you need to build a new blade? And also, there are other options as well beyond that. You see companies that are starting to grind these blades up into pieces and use them to feed cement kilns, either as kind of fuel to kind of fire the whole process, or as sort of the raw material in cement making. And then you also have groups that are kind of pushing to take advantage of the fact that these blades are so hard to break down and use them kind of as they are, or at least pieces of them, to make uh, bridges or transmission towers, or all kinds of kind of interesting ideas of for civil infrastructure. Um, and and so sort of thinking about sort of the challenges around the market for kind of creating the markets to drive recycling, the technical challenges. Um, I'm curious to talk with you about sort of the connection between policy and innovation. Do you think that having policies in place is sort of a prerequisite for kind of spurring that innovation to follow, or how do you see those the policy piece kind of coming into this? Julian, do you want to start?
Yes. So the policy is really non-existent in the U.S. at least, and as Jeff said, Europe's got more guidance there. And I think this is definitely a case where markets can be great for some things, but recycling requires some degree of coordination between a whole bunch of disparate parties. You've got the auto manufacturers, the battery manufacturers, and the mechanics who might be pulling a battery out of an electric vehicle. You've got the people involved with shipping those safely. And then there's this whole existing automobile dismantling and scrap industry. And then the emerging recycling companies. So there's a whole bunch of different groups there, which don't really have an established system for talking to each other and kind of coordinating and strategizing on stuff. So that seems like a great role for government to step in and sort of create the general framework for recycling to happen. If there's no recycling mandate for these batteries, we could hope that private companies choose to like do the right thing and establish their own recycling pathways themselves. But that creates this dynamic where people who are doing the right thing for the environment and for mineral supply are actually incurring extra costs, which would maybe make them less competitive against companies who choose not to bother with that thing, absent any rule saying they have to recycle. So just starting with a policy of like, you need to recycle your battery at the end of life, and clearly saying who's responsible for that would set the level playing field where everyone realizes, okay, we got to do something about this, and now we can start internalizing the cost of that into our sort of whole product life cycle. Also on the related topic of reusing batteries, which is different from recycling. Recycling is take them apart and get the materials out. Reuse would be, second life applications, or taking a battery that's no longer in a great state for driving a car with, and putting it on the grid as a energy storage plant. Help the grid integrate solar power and all of that. That works if it's low cost. You do have to do extra work to like calibrate these used battery packs, make sure they're safe and not going to catch fire, and be able to control them in parallel with other battery packs that have come from other cars. So there's work involved with that, and it can be worth doing if there's significant cost savings versus just going and buying a new lithium-ion battery. The big problem right now is there's no central kind of marketplace for acquiring used battery packs. And transporting them is also extremely expensive because of the current state of hazardous material regulation. So you end up with early adopters who are trying to do Second Life have to kind of hunt down these batteries, maybe find some at an auction here, or set up some bilateral agreements with a car manufacturer there. And there's small volume. It's all just it's not a mature market that is efficiently allocating resources, to the people who want them. So that would be an area where policy could come in and say, like, here's a framework for collecting the old batteries, assessing their health, and here's where the private companies can now come in and sort of compete on who can best collect them, who can best assess them, who can best put them to work.
Yeah, I would say that most of the folks I talk to, almost all of the folks I talk to, really put an emphasis on the importance of a regulatory construct to kind of prime the pump for the initial investments and the kind of learning curve improvements in cost that might be required. The EU's battery directive, it's basically an EU battery policy, which is kind of in the final stages of approval right now, gets at the kind of entire life cycle of lithium ion batteries in a way that is instructive. I think it requires recycling of batteries at end of life with responsibility assigned to the manufacturer or the automotive OEM. It also requires that, I believe starting in 2027, that new batteries being sold within the EU contain a certain amount of recycled content, which is bringing the whole concept into that kind of full circle, where you're going to not have to just recycle what you're throwing away. You're going to have to include recycled materials in what you're putting onto the market. There's a big project involving Northvolt in Sweden, and Umicore, a major metals processing company, that is, I think, claiming to be the first such kind of life cycle plant in the world. And so you're establishing the regulatory kind of imperative to not only start recycling as much as possible, but also to start to design the batteries that are coming off of the assembly line in ways that allow for the recyclability of those batteries, and to establish the channels that get that recycled content back into the batteries, right? One of the folks we talked to for this story mentioned that she's concerned for U.S. EV manufacturers, that if 2027 rolls around and U.S. companies, lithium-ion battery makers and OEMs, aren't prepared to somehow certify that their products are living up to that EU standard, that there might be some troubles selling their cars or batteries into EU markets. There's actually a kind of a pan-industry group that's working on a battery passport certification process that's meant to, sorry, I got someone sawing in the background. That's meant to basically get ahead of what might be a lack of, kind of federal or state level, regulations on that front, to make sure that doesn't happen.
Jeff's in an active construction zone right now. And I'll just throw in a tiny example from sort of what's happening in the wind industry in terms of thinking about this intersection of policy and innovation. So Siemens Gamesa is a major wind turbine manufacturer, and they recently developed this product that they call the Recyclable Blade, which they developed a new chemical process to make the plastic resins that sort of bind this fiberglass on the blades. The idea being that it's much easier to kind of dissolve the resin and recover those fibers once the blade is taken out of commission. But these blades cost more to make, and so they're more expensive. And just the person I was talking to from Siemens Gamesa was saying that in a few countries in Europe, France, Germany, and Belgium, they're starting to think about requiring, when companies put bids out to develop wind farms, they're starting to think about requiring them to develop end of use plans as well. And so, something like that could potentially give an advantage to a recyclable blade that costs more upfront, but potentially means that in 20 or 30 years, the developer has less of a headache when it comes time to deal with those blades. And just moving on to the next question, I'm curious to hear in your reporting if there's anything kind of exciting or surprising that you came across. I'll throw out my own example just to start, and I kind of mentioned it, this idea of reusing blades for utility poles. I thought this was so cool because you have the blade that generated clean energy in its working life, and now it's being used to sort of carry clean energy or electricity in general over long distances as a tower. So that was something that stuck out for me. Julian, is there something that you thought was particularly cool?
Yeah, there were a few things. One was just that people really are working on this right now. I think I went into the reporting with this perception that, okay, we don't have cost-effective lithium-ion battery recycling today. This is going to be a problem in 10 years when there's so many batteries coming off the line, at the end of their lives. It turns out it's happening now. The manufacturing new batteries creates scrap, and there's cells that don't pass quality control that need, those are waste streams today. And it turns out there's this pretty robust ecosystem of startups raising significant funds today and building factories today. So yeah, I was just surprised at how active the space is. I think a little bit out of the public spotlight, but now we don't have nearly enough recycling capacity as it stands. But like in the next few years, we'll be in a drastically different situation than we are today.
I think the song is stopped, so I'm safe. Yeah, I think I was, first of all, I feel like I'd learned a lot more than I expected to about the complexities of establishing the entire chain of kind of custody for these products, the issues regarding liability of folks who are taking, say, a car, an EV, pulling the battery, moving that battery to a place where it can be safely stored, moving that battery from where it's being stored to some central recycling facility. And every part of that chain requires some kind of level of surety between the parties that are making that handoff from point to point. That's one of the areas where I think establishing kind of a regulatory framework is really important to give every party to that multi-transaction process some kind of sense of certainty that they're doing it right, they're not going to get dinged for it, and that they've got some kind of established value for their role in that transaction. And then I guess I'm also intrigued by the efforts I learned about that are underway at research labs like NREL, and I'm sure at multiple kind of battery and solar panel manufacturers, to really build in recyclability and reusability into the initial product. There's an enormous effort on circular economy on this front, and we talked to some folks at NREL who were involved in that. Establishing different. You probably know about this more than I do, Maria. Different kind of mixes of polymers that you can use in wind turbine blades to allow them to be more easily kind of disassembled at the end of life. Using different materials in solar panels that will allow for their reuse. Talking to one researcher working on perovskite, solar cell development, which is still quite a ways out, but trying to find less toxic dyes and more easily kind of disassemblable kind of materials processes, so you can make sure that you can take those things apart. And I'm sure the example of taking the cathodes and kind of reusing as much of their fundamental structure as possible. There's a chart that came from that Rebat Center in DOE that shows some really big savings in energy and waste for direct recycling, which is another way to say kind of remanufacturing those components. It's so much better than either melting them or dissolving them to get what you want out of them. I guess the real big question is, what is it that gets the people who build these things to decide that they are going to invest the time and effort to design around those imperatives and what are the regulatory and kind of economic or corporate ESG drivers that are going to make that happen. That's going to be really interesting to watch.
Yeah, Jeff, you brought up a really good point about this idea of circular economy. And I've just noticed that we have a couple questions in the chat that have kind of asked, what about reuse, or, why the focus on recycling per se. And I would say that I think in all of our stories we say recycling, but we have kind of encompassed other ideas, right? Reusing turbine blades, like I said, for utility poles is just one example, but also this idea of and Jeff, you were talking about this, using different polymers, kind of designing it differently from the start. So it's easier to recover those materials later in life. You use less of those materials, ideally. And you are kind of working with other users of these materials, like, for example, fiberglass has many applications, like with automobiles, etc. So how can you make sure that when you're making material, it's none of it's being wasted, it's always being used for something. Maybe if just kind of we can open up the audience Q&A there, and if either of you want to add anything else to circular economy. I know it's a very large kind of squishy subject to define.
Well, I did have some thoughts on the audience comments around reuse, and I think you're totally right that it would be leaving a lot of value on the table if society's built a framework purely about recycling and left out the reuse, especially with batteries where, they'll typically come out of a EV when they're down to like 80% of their capacity as a rule of thumb. That's still a lot of capacity. And if you're not space constrained, as in you're building a power plant in the middle of the desert somewhere, that's absolutely useful capacity to have. So in my reporting, I've only found one US power plant that's storing electricity and bidding into the wholesale markets with second life batteries. And that's in Lancaster, California, by this company B2U Energy Solutions, and I think it's a really important proof point that if you're smart and creative and a little scrappy, you can make this work. Like, you can get your hands on enough of these batteries I think they're up to 17 megawatt hours now, which is not big by massive battery plant standards, but it's substantial. It's a utility scale project. But I haven't seen anyone else replicating that yet. So what the entrepreneurs there say is absolutely they can generate enough money from the reuse of the batteries to then more than cover the cost of recycling. They're making profits in the meantime. But I think we could actually run into an interesting tension down the road if we get a really robust battery recycling sector. They will be incentivized to get as much volume coming into their factories so that they can process them and get more materials out of them. And that could end up being a bit of a cross purpose with the reuse sector, which wants to hold on to batteries and get as much use out of them before they go and get dismantled. So, it's way too early for that to be like a real source of friction in the industry. But I'm going to be interested to see how we play that out and, do the policymakers favor let's make recycling the ultimate goal here, or is it let's reuse as much as possible and then recycle? And depending on how you define the priority there, you'll want to have different policies in place.
Yeah, you got to think that we already got a bunch of stuff that's going to be thrown out in the next 10 to 15 years that we can't go back and redesign to be reusable, right? We got to figure out something to do with that. And at the same time, the volume of stuff that is already built that's going to have to be recycled or reused in some way is going to be dwarfed by the volume of stuff that is going to reach end of life and have to be recycled, reused, or repurposed, or remanufactured in, say, 2040. It's a really complicated kind of set of equations, I'm sure, for anyone who's trying to decide where to direct their kind of technological development, efforts, or to invest their capital. Once again, this would be a place where, regulatory kind of guidance, both sticks and carrots, I think would be very helpful for folks to direct how they kind of, you know, stack or kind of phase those different efforts that are going to be addressing different issues. You know, there's a question here in the Q&A about what do you do about when people start figuring out battery chemistries that don't need cobalt. And cobalt's the most valuable mineral, I think, out of the entire kind of cathode that you can pull out. Getting rid of it, there are a lot of reasons why you want to make batteries that don't need it, but it does reduce the recycling value. So are there processes that are flexible that it can be used for, you know, the batteries with cobalt today and repurposed for lower value batteries in the future? I don't know. Tricky.
We had a couple of questions too that were about minerals in particular. This idea of, you know, is there a national security kind of component, or kind of domestic component to, you know, recycling batteries, or are there discussions? Are there ways to reduce the minerals and materials used in batteries? Jeff, you kind of just touched on this with cobalt, but do either of you want to elaborate on that idea of sort of national security and or kind of material reduction in batteries?
Yeah, I could jump in on that. First, I'll give a plug for the latest episode of the Carbon Copy podcast. I was speaking with the host Stephen Lacey on this exact topic, actually, of like how battery recycling could really be a tool of national security in this post-Ukraine invasion world where mineral prices are spiking, and, you know, depending on any one geopolitical adversary to supply your critical minerals is an increasingly tenuous proposition. So basically all the battery recycling companies I talked to are explicitly saying their goal is to create a sustainable domestic U.S. source of critical minerals for future batteries. And, you know, they're making some bold claims here. Like a lot of these startups are sketching a vision where they get so good at profitably taking apart old batteries and pulling out the valuable ingredients that it's cheaper to make new batteries with recycled materials than with freshly mined materials. And, you know, they're sort of painting a picture of a world where we don't really need to mine or maybe don't need to mine as much because we've got so much coming out of the recycling stream. You know, I would put a big asterisk next to those because we still need to see these companies prove in real practice that they can get materials cheaper and remanufacture new cathodes cheaper than conventional methods. And then there is this volume mismatch of the amount of old batteries ready to be recycled is just going to be a tiny fraction of the future demand for new batteries. So like I still don't have a great sense of how many years down the road it's feasible to get a significant portion of our new batteries from the recycling, but certainly it's going to be a lot easier to recycle batteries in the United States than to open up new mines, you know, like all the environmental regulations, which are there to protect the environment, make it a very lengthy and expensive process to create new mines here. And so if we do want to shore up domestic supplies, there's recycling is probably going to be the key pillar of that.
Yeah, I mean, I would just, I guess, kind of like build on that. We're always going to need to make more batteries every year than we'll have batteries that are getting thrown away, obviously. I don't know when that stops. So on the other hand, I guess if I was someone who had to go out and try to buy metals, increasing amount of metals every year to build a bunch of batteries, I would sure love to hedge against the volatility of global minerals markets and supplies by having some kind of like, predictable stream of recycled materials coming back into my supply needs, right? I may even decide at some point that whatever cost and uncertainty that's involved in designing the next generation of batteries to be recyclable, is worth it because of those calculations of how much I can offset that exposure to risk. And there also, I think we should definitely think about the environmental and social and governance imperative. I was talking to one CEO of a kind of a next generation kind of electrolysis based recycling company, Megan O'Connor of Nth Cycle, who mentioned that the initial value for US OEMs in the absence of any federal regulations is really about establishing the environmental bona fides of the batteries that they're producing. We all know that EVs are far less polluting than internal combustion engine vehicles, right? But bringing that down even further by being able to establish that the batteries are being recycled, that those lithium-ion batteries aren't getting landfilled, that you are reducing the amount of energy that goes into mining as compared to energy going into recycling or remanufacturing. That's all got value as well. I don't know how to calculate that value myself because I'm not in the ESG suite of Ford or GM or something like that. But that's an important value that will most likely be an important early driver. It'd be nice to have regulations as well.
I see we have another question asking if we'd be willing to share a list of resources or more about startup companies. Actually, tomorrow, I believe, we'll be publishing a story that kind of highlights a lot of the startups and companies that we've mentioned in our stories. And certainly each individual story, anything that we've kind of talked about here, any figure that we've thrown out or report we've cited, most likely we'll have linked to it in one of our stories. So if you go to Canary's website, the Recycling Renewables page has everything there. And I guess maybe we have a couple minutes left, so we can end. I'm curious to hear what either of you, if in the course of reporting for the series, if you're feeling now more optimistic about sort of this question of recycling renewables, or if you're feeling overwhelmed, daunted, maybe all of the above.
I feel like I didn't know how hard it was. So I feel like I was by the process of learning, I'm less sanguine about the ease of kind of scaling it up. But I'm also really kind of intrigued and inspired by all the work that's being put into building up the recycling chain, establishing the regulations, building reusability and circular economy into products. So I would say I'm definitely optimistic. I mean, it just makes sense.
Yeah, I actually came away feeling more optimistic than I expected to on the battery prospects, battery recycling. And it comes back to this theme I keep seeing again and again in the clean energy transition, where people in the early days want to throw out these criticisms or critiques of like, well, you don't know, there's this one problem with this whole electric car revolution. Like, they run on coal, don't you know? And there's a tendency to not recognize the changes that are already happening and that the future won't look the same as it is today. So certainly it's correct to say if we kept our industrial footprint today for recycling, it wouldn't work in 10 years or 20 years to deal with the volume. But people are working on it. There's like smart people, there's a lot of low-hanging fruit and money to build the factories and stuff. So yeah, no, I came away thinking like, there's no reason we can't do so much better than we have on recycling batteries.
Yeah, I myself found it kind of encouraging just to learn about how much activity is happening in the wind turbine industry in particular. Obviously, action is different than words, but right now, a lot of the manufacturers and major developers are pledging not to send any turbines into landfills, and if they do that, if they're true to their word, that would be significant, and that means if they're not going to landfills, that these companies are thinking about what do we do instead, and kind of all the different things you can do with the turbine or ways you can use it. So Yeah, I was funny thinking about the answer to this question. I was like, I feel more worried about other things in 2050. It seems like with recycling, at least we got, we have a good grip on the problem.
Indeed.